what we are going to do is do one more of these solving systems by eliminations situations that we did earlier. I'm going to go through this one with you guys on here so that you can watch it, pause it, copy it down, things like that along the way. We know I'll try to keep the colors in the same order even though we did them earlier. We know that step one is to pick two equations that will cancel nicely. In this problem, actually, we have quite a lot of examples of things that will cancel nicely if we just turn one of them negative. We could eliminate the x's that are in the front. We have that top and the third equation are both x's. The middle, we have options for the first two, where there's two y's. We have two z's that would cancel nicely. We have a lot of things we could cancel here. I am going to cancel the x's just because they are in the front, and it's the easiest kind of thing to go through and cancel since you can see them the most readily. So we're going to pick the top equation and the bottom equation. I will put them over here. X plus 2y minus z equals 2. And x minus y plus 2z equals 5. Oops. Get rid of that for you. Sorry about that. What you want to do at that point is we have to make one of these so that they are cancelable. We're going to take everybody on the bottom and multiply by a -1. That'll give us negative x plus y minus 2z equals -5. When we're multiplying by a -1 like that, what that does is it just flips all of our signs, but it keeps our values the same. And I will add our other equation right back over top. Minus z equals 2. Now we can look at it and we can see our x's will cancel. They're in a good spot to eliminate out. Those will cancel, leaving us with 3y minus 3z equals, adding straight down, 2 minus 5 is a -3. That is a good place to be. We now have something with just two variables in it. And then we can go to blue like last time. There we go. And we want to also eliminate the x values. Again, we want to make sure we're eliminating the same variable that we eliminated last time. So we are going to take this middle equation that we have not used yet. We'll put them in the middle. 2x plus 2y plus 2z equals 12. And we can use either one of our equations. Let's just use the bottom one since we are familiar with it. X minus y plus 2z equals 5. Remember, I got the z's have that little line through it so you can tell. And we want to make it so the x's will cancel, just like we did in the problem during class today. We need to make this x, don't forget there is a secret little 1 in front. We want to make that x a -2. The best way to do that would be to multiply everybody involved by -2. What that will do, I can put it over here, by -2 will give me -2x. That would give me a positive 2y, a -4z, and -10. Let me actually move that 10 down so that it doesn't look so strange on your screens. If we move this over just a hair. There we go. We can put that -10 in there. 5 times -2 is a -10. And we're going to keep that first, that it was our middle equation. We're going to keep it the way that it was, because they will indeed cancel. Z equals 12. There we go. Those will cancel out the way that we want them to because you're looking at the two x's. You know that a negative 2x and a 2x will eliminate straight down, leaving me with 4y minus 2z equals 2. That now gives me a second two-variable equation. I've got y and z over here. I've got y and z over here. So that is exactly what we want. Then we can come in, I'll use the purple. We're going to take our current 2 by 2 system, 3z equals negative 3, and 4y minus 2z equals 2, and we're going to solve our system that we have. We want to continue, we're going to keep continuing to solve by elimination. I can look at this and say, well, let's just get rid of the y's. They're in the front. It's the first variable that I see. And I know that I need to turn the 3y and the 4y into the same number. I need the lowest common multiple again. So the lowest common multiple I know between 3 and 4 is going to be 12. So I want to turn one of them into a positive 12 and one of them into a negative 12. So let's turn the top into a positive 12. If I want 3y to be 12y, I have to multiply everybody by 4. 3 times 4 will give me 12y. Perfect, that's what I wanted. Negative 3 times 4 will give me negative 12y. And negative 12y, oh boy, 12z. There we go. Let's fix that. And negative 3 times 4 here will give me a negative 12. Lots of 12s to go around here. I want, in this case, the 4 to turn into a negative 12 because I want them to cancel. So my best bet would be to multiply everybody by negative 3. Negative 4 times negative 3 gives me negative 12y. Those look like they're going to cancel very nicely. A negative 2 times a negative 3 gives me a positive 6z. And 2 times negative 3 gives me a negative 6 at the end. Those will do exactly what we wanted. They will cancel. They'll eliminate. So it's okay. We'll go straight down. Negative 12 plus 6 gives me a negative 6z equals negative 12 plus negative 6 equals negative 18. Going to our full normal one-step equation life, we can divide both sides by negative 6, which will tell me that z is going to equal a positive 3. Perfect. We know one variable. That's the best case scenario right now. I'm going to move this stuff up a little bit just to have some room. And then we will go down that next little column. I know that this gets messy and it kind of is a lot to look at. I hope that switching the colors kind of helps a little bit. We can take what we now know is that z equals 3, and we can plug that back into one of our equations from up here. It does not quite matter which one. I personally would do, let's do the top one. So we'll plug that in and we'll say 3y minus 3 times z, which is 3, equals negative 3. Lots of 3's abound again. 3y minus 9 equals negative 3. Solving just like we are used to. We want to isolate the variable, move the 9 over. 3y we haven't touched. We're going to add 9 to both sides equals 6y, giving us 2 when we divide. We are killing it. We're on track. We now have 2 variables solved for, meaning I can come over here. I'll use this like reddish orange color for our last little bit, our last exciting movement. We now get to pick any of those 3 equations back from the top. I say we use the top one because it's there, it's available, so we can find out what x is. So let's use this top one plus 2y minus z equals 2. Why the heck not? And we'll plug in what we know. X is there, plus 2 times y. Y is 2, minus whatever z is 3, equals 2. All right. Clone them up. We've got an x here. 2 times 2 is 4, minus 3 equals 2. We're on the home stretch. Combine our like terms. X plus 1 equals 2. And I know you know that last little step to subtract 1 from both sides. 2 minus 1 is 1. Telling us that x equals 1. And with a sense of finality, we can come over here and in our little solution bubble of the middle that we have built ourselves, we can say that x equals 1, y equals 2, and z equals 3. That is, just for you guys, another example on solving 3x3 systems by elimination. I hope this helps. Pause it as you need, right along with me as you need to go, and I will see you soon.